Okay, chemistry students, this is problem 3.44 in the chapter 3A homework, and it is actually about kind of orbital diagrams and electron configurations, which we covered in chapter 2. Okay, so before we actually do the problem, I want to go, we are going to, and we're going to do this rubidium with the 1+ charge. But I want to show you, you had a figure in your book, figure 2.6, that I put in the blocks of the periodic table document for chapter 2. So this document has a figure where the orbitals are drawn as lowest energy 1s, then the 2s, then the 2p, etc., etc. up. If you look at this order, the order on the far right, these are the exact same order that you would follow if you were completing electron configurations from the periodic table. So having this in front of you, it's easiest if you have this figure 2.6 in front of you, either from the book or if you've printed this document. Let's go actually to OneNote. So I just pasted the periodic table image from your book. Okay, so plain periodic table. Rubidium is over here, number 37. So I'm just going to kind of go away. Now, erase that black. So the easiest thing for plain rubidium, the easiest cheater way would be to say, okay, the noble gas ahead of it is Kr. And then just do plain Jane rubidium, which is, if you look in period 5, then it would be 5s1. Okay? But we're going to actually go through the whole thing. We're going to go through the whole thing reading across. So following that row, that period is 1s2. And now here, I'm just going to kind of strike through where I'm at, what block I'm at, is 2s2. This is the P block, and we're totally, since we're going all the way down to element 37, we're totally filling it in. 2p6, 3s2, all the way across to 3p6, all the way across to 4s2. And now remember, we lower our number in our D's, 3d10. And now just to check, where are we? So we don't do 3p6 again, 2, 3, 4. So starting here, all the way to 4p6. So everything that I'm circling is technically the Kr, okay? And then rubidium, we're in period 5, so we would have 5s1. So that would be the whole thing listed out. Now as orbitals, I've been drawing them left to right, because we read left to right. So there's the 1s orbital, there's the 2s orbital, there's the 2p orbitals, 3s orbital. So if you're filling in the electrons, just starting from here, you're just filling in a whole bunch of electrons, okay? The 3p's, 3p, and then 4s, and then I actually want the d's in there. I'm going to do 1, 2, 3, 4, 5. All of those are the 3d's, and it's totally full, and I know I'm writing skinnier here. Okay, but everything is full. These are all the electrons of this element, okay? And because we generally write left to right and read left to right, we initially start electron configurations and orbital diagrams just left to right. But technically, remember that this shell number, this 1 and this 2 and this 2, represent energy. So if we actually graph them as a graph, kind of, we're going to draw the 2s higher in energy than the 1s. And we're going to draw the 2p higher than the 2s, and on and on and on. You're still following the same order that we followed on the periodic table, as long as you know your blocks, and the same order as the electron configuration, but you would just list them in the energies that you see here. all that they did was show the shell. Oh, I can't draw on this. All they did was show the shell 1, 2, 3, 4, 5, and then the actual orbitals on the far right. Now the 4, it does split up a little bit. The 4s is lower in energy than the 3d, but if you just follow the periodic table, then you're fine. You just follow the order on the periodic table. You don't need to memorize this order. So on this homework problem, just to be clear, we're doing rubidium 1. So you're going to lose from the highest number, the highest shell, which I'm circling there, is the 5s1. Rb1 plus is technically, since I'm lazy, Kr, and if you wanted to, you could say 5s0, okay? To be super clear that there was an electron in that 5s orbital and it's gone now. Rb1 plus is energetically similar to Kr. It wants to be like Kr, wants to have the octet in its outermost energy, and it will once it's lost this random 5s electron, okay? So if we go back to the actual problem, you're just going to take and click on the orbitals. It will fill in the energy. So 1s, 2s, 2p, 3s, 3p. Now I got to make sure I find my 4s. And it's, you see how it's filling in the energies in the appropriate order. There's no electrons yet. 4s, where's the 3d? He's next. 3d. 4p all the way up to 6 is next. And then remember the 5s is going to be empty. So I am going to put him in there. I might get it wrong. We'll see. I'm going to put him in there, and I'm not going to put any electrons in there. So then I just click, 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 click. I know this takes forever, but you're adding in your appropriate electrons into the orbitals. They're already listed, and look, it filled it in at the end for you. Exactly what I've shown you already. So let's submit. 5 attempts remaining. Let's see if I get rid of the 5s if it's happy. Oh no, do I have to reset the whole thing? Yuck. 1, 2, 2p, 3s, 3p, 4s, 3d. Let me make sure I got 2s, 2p, 3s, 3p, 4s, 3d, 4p. Let's just do that. Because Rb plus. I should have checked if they wanted the 5s. Yay. Okay, so the 5s it doesn't want. So that's the first one, okay? And it's even telling you what it looks like, okay? You can do the same thing for parts B, C, etc. That is this problem 3.44, which is number 44 in the 3A homework. So hopefully that helps answer some electron configuration questions. Thank you.